Welcome back everyone to this last technical topic lecture on pivot tables with pandas. And then after this, we'll actually have the section exercise. So let's talk about pivot tables. They allow you to reorganize data and they allow you to refactor cells based on columns and a new index. And this is actually best shown and explained visually. So let's take a look at this visualization from the pandas documentation. Essentially, the main idea is that a data frame with repeated values inside of its columns can be pivoted for reorganization and for clarity. So here we have an original data frame on the left-hand side, and we have 4 columns, foo, bar, baz, and zoo. And then we're going to call the .pivot method on this data frame, and we have to choose what the new index is, what the new columns are, and then also what the new values are going to be. So we choose columns from the original data frame. So essentially we have 4 choices from the original data frame, foo, bar, baz, and zoo. And then we pass in those columns to define what sets we want for the new index, columns, and values. And you should notice that how the choices for the new index and the new column values should have repeated values in the original data frame. So in the .pivot command, we chose the foo column for the index. And you'll notice the foo column in the original data frame has repeated values. We have 3 1s and 3 2s. So then when it moves on to the index, we essentially just take the unique values there. And then we also can see that the bar column is what we pass in to now define the columns after the pivot. So then we can see that we have the repeated values ABC, ABC. And now each of those unique values is a new column. And then we have to decide where are we actually going to match up for the cell values. And we decided to choose the baz column for that. We could have also chosen the zoo column as well, since those are all unique values. Usually your values should be more or less unique, but what this is actually showing you here, as far as the pivot is concerned, is it's just showing you what values are related for each unique value matchup in the index and column choice. So if we take a look at the original data frame, for instance, what lined up with foo is equal to 2 and bar is equal to a? That question is a little harder to answer in the original data frame because I have to first go to the foo column, look at the number 2, then I have to look at the bar column and see where that matches up with the letter A, and then finally I can see, okay, baz was number 4 for 2a. If you have that sort of question, it'd be easier to just do a pivot table here, or really it's called a pivot method, and then this is a lot easier to answer of what value for baz is matching up with foo of 1 and bar of a. We can just quickly see that it's something like 1. Okay. So you should also notice how all the information from the zoo column is actually now discarded. So it doesn't actually come over after you call .pivot. And probably the last but really important note here, when we're calling the .pivot method, not the .pivot table method, which we'll discuss in just a little bit, but when we're showing the .pivot method, we're not actually displaying any new information. It's just merely being reorganized. In fact, slightly less information is being shown after the .pivot command because we dropped the zoo column. And here's a really important note. If you're an Excel user, you're probably really familiar with pivot tables, especially if you're an advanced Excel user, and you have some intuition of when to use them. But I should note that for people that are first coming up with spreadsheets from a Pandas and Python perspective, is that it often doesn't actually make sense to pivot every single data frame. And not every single data frame is going to be able to even be pivoted in a way that makes sense. And pretty much all of the data sets used in this course, especially when we have this data set lined up for a machine learning task, there's not really going to be a need for a pivot table operation. So while we are going to be discussing pivot and pivot table methods in this lecture because it's a really common student request, we're not actually going to be using pivot and pivot table methods throughout the course. However, if you do find yourself having the urge to call .pivot or call .pivot table, I'd highly suggest that you actually run a checklist, as in, what question are you trying to answer? And what would you like the data frame that answers the question to look like? Does it actually need a pivot method call in order to achieve that data frame? So again, what do you want that resulting pivot to look like and that resulting data frame, and does that actually answer your question? Usually, you can use a .groupBy call to answer that sort of thing. So talking about group by, Pandas also comes with a pivot underscore table method that allows for an additional aggregation function to be called. So this aggregation combined with the pivot table is probably where Excel users are really familiar with pivot tables. But Alternatively, with Pandas, we already know that we have this .groupBy method call that we can use that, in my opinion, is a little more convenient than trying to figure out your pivot or pivot table. Again, it kind of depends on the circumstance. But let's explore now in a Jupyter Notebook both the .pivot method and the pivot table methods in Pandas. All right, here I am at the Jupyter Notebook. Let's go ahead and read in the file we're going to be working with. It's located underneath the Pandas folder. You simply say pd read csv, and then we're going to call sales funnel crm.csv. So CRMs, or customer relationship management systems, it's really common that people use pivot tables on these. So we're going to go ahead and explore it just a little bit. Here we can see, let me zoom out a tiny bit so we can get a scale of what's happening here. We have an account number, we have a company that we're trying to sell something to, we have a contact at that company, and then the person on our team who's the account manager for that particular contact, the product we're trying to sell to them, the number of licenses we're trying to sell, the total sale price, and then the status, whether we've already presented the opportunity to them, whether it's under review, whether we lost it, or if we've already won and closed the deal. Okay, so very typical to see a CRM sales funnel data frame like this. So let's go ahead and explore how we can use the pivot method to try to get a little more clarity if we're trying to answer some questions. And I would encourage you to take a look at just the help documentation for pd.pivot. By calling help on it, you'll actually see you can create this little data frame. It's the same one I showed in the previous slides, and then it'll show you a bunch of commands you can actually call on it. So super useful. Go ahead and check that out, but we'll go ahead and explore it on our own right now. So we have this data frame. What we're going to do is, let's imagine that we wanted to know how many licenses of each product type did Google purchase. So if we come over here, we can see I have the company, I could see Google, and then I have the licenses, but I want to know how many licenses of each product type did Google purchase. And right now, the way it's set up, it's a little hard to answer because I have these other columns in the way, so I have to go from company Google and then jump over. And the other thing, if this was a really large data frame, I wouldn't actually know if Google was further down the data frame, because maybe Google would have been in row 100 and I wouldn't have been able to view it. So luckily, right now, it's the first 3 rows, but that's basically just for the purposes of this presentation. So what we want to do is we want to know how many licenses of each product type did Google purchase. And currently, it's a little hard to read this way, so let's go ahead and pivot to reformat. And the first step you should do is just select the 3 or few columns you want to actually work with. And so what I want to know is the company, specifically Google, the number of licenses, and the product for each one. So we're going to come over here and just take a subset. We're going to call it licenses is equal to df, and then pass in that list of columns. I'm going to work with the company column, the product column, and then licenses. And I just want to note here, you don't technically need to do a pivot to answer this question, but it is going to make it a lot easier, especially if the data frame could not all be read at once. So then we take a look at these licenses, and now I only have those columns, so it's time to pivot. So what we're going to do is call pd.pivot. The data that we're going to pass in is licenses, and then I'm going to set the index to be company. Recall that typically you want your index column that you're providing to have repeated values, because really what's going to happen is the index is just going to be the unique then company. So we'll have an index or labeled index for Google. And then that means I want the columns to be the various products that we sell. So here we're going to have analytics, prediction, tracking, and keep in mind if there's products that we haven't sold licenses to Google yet, they'll just show up as NA when it comes to the actual license number. And so the value I want here is going to be, or the values I should say, it's going to be the actual licenses column. Okay, so let's go ahead and pivot that. And you'll notice after running this, you have a bunch of not a number or null values. And that makes sense because we haven't sold every single product to every single company. And in fact, if we take a look now at Google, and you could always just use indexing to grab only Google off this data frame that's returned here, is that we can see we've sold 150 licenses for analytics, none for GPS positioning products, and then 150 for prediction, and 300 for tracking. So now it's a lot easier to answer the sort of questions of how many licenses of each product did we sell to a particular company, versus trying to come back here and then use filtering to do that. Granted, you could do this and answer the questions without a pivot table. You would just start saying, okay, give me the DF where the company is equal to Google, and then you would start looking at the product and licenses company that way. But here is a really nice presentation where you can then start comparing, and maybe you could answer a question like, what was the company we sold GPS positioning to? And very clearly you can see it looks like Cisco was the only one we actually sold something to in regards to GPS positioning. Okay, so that's just the pivot command. Recall pd.pivot. Remember, it's pd.pivot, not df.pivot. You call it off of Pandas. That just reorganizes your data based off a new index, new column values, and then what you actually want the cell values to be. What we want to do a lot of times is actually then perform some sort of aggregation call on top of this. And that's where the pivot table or pivot underscore table comes into play. So the way this works is, if we take a look at our original data frame, we have this information, and let's imagine that we wanted to now get maybe the total sum of the licenses and the sum of the sale price for each company. Essentially trying to answer the question, how much have I actually sold to each company, total sum. Technically, you could do this with a group by, but it's possible with a pivot table. Depends on exactly what you're trying to achieve, which method you choose. I personally prefer group by method calls, so I try to do that before I start using pivot table, but again, it's kind of up to you. So we're going to pass in our data frame first into pivot table, and then we have to choose what's the new index going to be, which is essentially what you're actually going to group by. So we say, okay, go ahead and set the new index to be by the company. So it's going to essentially group by the company column. And then we're going to pass in the data frame as our data source. And finally, what's the aggregation function you want to actually use? You can use any of the aggregation functions we've discussed earlier in the group by methods. You just pass it in as a string. So in this case, I'm going to sum them up because the question I'm trying to answer is, how much have I actually sold per company? Now keep in mind, this will actually perform a sum for every single numeric column. So if you run this, it actually also sums up the account numbers for every single company here, which doesn't really make sense to sum up all the account numbers for Google since that's kind of meaningless, but it does make sense to sum up total licenses sold and the total sale price. So here I can see now quite easily that I have sold 600 licenses to Google for a total number of sale price of like $3.15 million. Okay, so again, keep in mind, we could technically be answering these questions with a group by. I could have just said df group by the company column and then call sum on this, and that gets you the same results. So whichever one you prefer. Again, I mentioned that I'm partial to preferring group by method calls. I think they're a little simpler and easier to read, but if you're coming from Excel and deal a lot with CRM data, you may prefer the pivot table methods. Now, I mentioned earlier, it didn't really make sense that the account number here is also summed. So what you can do is, if you want, you can actually provide the values argument and provide a list of the columns that you're actually interested in, essentially selecting them after the fact of the pivot table. So then we can say sale price and licenses are the values that I'm actually interested in seeing the sum for the company. So you can see that pivot table is kind of pretty readable. You can just say, okay, here's my data source. I want the index to be grouped by company. Give me the sum of licenses and sale price per company. So you can see here, after you run that, you get licenses and sale price instead of also the account number. And now finally, let's go ahead and go through one last example. It's going to be analogous to the multi-level index examples we saw when we group by multiple columns. What we'll do here is we'll go ahead and say use pivot table, but I'm going to pass in 2 columns for the index. So if we take a look at our original data frame, df, I have both a contact and an account manager. And we can see that account managers can have multiple contacts. So here we have Ed Thorpe with a contact of Larry Pager at Google, but then also Elon Musk at IKEA and Tesla. So let's imagine I wanted to just see the account manager and then maybe the total number of licenses or the total number of sales that person has come into play with, as well as the list of their contacts. So essentially what I want to do is I want to group by the account manager and then the contact, and get the total sale price per contact. So let's go ahead and try that out. We're going to say pd.pivotTable. I'm going to pass in df since that's what I'm working with. And then for the index, I want my outside index to be that account manager. And then I want the inside level index to be their contact there. The actual values I'm interested, let's go ahead and just say I'm interested in the sale price. So we'll say sale price. And then I have to choose an aggregation function. So we'll say, give me the sum of the sale price. So what this is going to answer is the total sum of the sales that an account manager has done per contact. So we'll say then aggregation function is equal to sum. So we run that, and here we can see we have two account managers, Claude Shannon, Edward Thorpe, and then their various contacts. There may be people with 0 contacts or 1 contact, 3 contacts, etc. This number doesn't have to be fixed, and then the total sum per contact. So it's essentially kind of a group by account manager, then contact, and then sum, and only call the sale price column. So keep in mind, the columns are optional. They provide an additional way to segment the actual values you care about. And the aggregation functions are applied to the values that you list. So what we could do is say here, add in a parameter called columns, and we're going to add in a parameter there for a product. Go ahead and say product there, run that. And so now what this is going to show you is the sale price separated out by product. So here we're dealing with kind of 2 tiers of multi-index levels. 2 tiers for the index, and then 2 tiers for the actual columns, where we have an overall sale price, but now it's broken down by the actual product type. So we've sold, for example, Ed Thorpe has sold Elon Tusk 7.35 million total in analytics, and nothing in GPS, 700,000 in prediction, and nothing in tracking. Now, we don't actually know if Ed Thorpe has done all these sales in one go for Elon, because right now we're just taking the total sum. So just keep that in mind. And something to note here is if you don't want these to be null values, maybe it makes more sense to fill these in with 0. There actually is a default fill value parameter, very similar to the fill values we saw when we were talking about dealing with missing data. You just say fill_value is equal to 0, and any null values will be filled with whatever value you want. So in this case, we'll just go ahead and put them at 0 since that makes sense for us. And another thing I want to point out is you can technically pass in more than just a single function call here. You can actually pass in direct NumPy calls. So if you want, you can pass in a list here. Instead of the string sum, I could say np.sum, and that will run the NumPy sum function. So you get the same results here. But what's nice about doing this is I can actually then call for multiple NumPy functions like np.mean. So then I want both the total sum. So notice here we have yet another outside index level, sum of the sale price per product. And then we can also get the average. So run that as well, and you start getting these very large data frames here. So then we can see the total sum that Claude Shannon has sold in analytics to Cindy Phoner. And then I can also get, on average, what is the sale price? Are they doing this all in one go, or are they doing it in 2 goes, etc.? So you'll notice that we can see here directly the mean of analytics sales versus the total sum of analytics sales for Claude Shannon's contact Cindy Phoner. And something to keep in mind, especially with the pivot table command, is that it can get really messy really fast and really hard to read really fast because now you're just aggregating too much data. So always keep in mind, you're trying to simplify things, not make them more complicated. So for example, in this case, I set the products to the columns, but it might even make more sense to just do sum or mean just one at a time. So just have np.sum here as a single data frame. And this is still maybe not as easy to read as setting the product as another index. So maybe we, instead of just having it as a column, we remove that there and then have it as yet a third index. So we can say product, run that, and then I get this nice little table. So whether or not this is easier to read Really depends on, again, who you are, what you're trying to answer here. But remember, you can always kind of play around with having something in the index versus spreading it out to a column. The very last thing I want to point out here is there's a convenience parameter called margins, and it's a little not clear from documentation what it's actually doing, but essentially what it does is it's either true or false. It's a Boolean, default is false, but what you can do is set it to true, and what it's going to do is give you a grand total at the very end at the margin. So if we take a look at that, what it's going to do is if we exit out and just say here at the end, comma, margins is equal to true, and run that, you'll notice at the very bottom it does this kind of grand total. So kind of useful for certain situations, especially for things like formatting. So then you could save this, save it as an Excel file, send it to your manager, and then she or he will be very impressed by all the work you did in just one line of Pandas. Again, kind of a really long line, so always keep in mind what questions you're trying to answer and whether or not it's worth it to try to figure out the pivot table. But you can check out the lecture notebooks as well as the pivot table and pivot documentation in Pandas online for more details on all of these processes that we've gone over. Thanks, and I'll see you at the next lecture.